So the next portion here is to do the computation. Basically, we now need to implement this formula in our assembler program. So this is what I am picturing with respect to the ideas of the shift instructions. We can say that, okay, so before we display the result, we're going to do this computation. So let's walk over this. So we have a product, we have a multiplier, and we have 3 multiplicants. So step number 1, of course, the idea of doing something like this can be implemented as a sequence of steps like this. So our result, or let's even say product, right? So this is our product. So the product will be a sum of the multiplier times 2 raised to the k multiplicand, actually we're using m, km and n, right here, km and n. All right, so this is the idea. And of course, we can set product equal to 0 so that we can repeat this computation next time. We can always reset product to 0 before we begin addition. Then we use register EAX to store the multiplier. Then we use register CL, which we can use with our shift left instruction to do the multiplication. And so basically we'll be taking multiplier and shifting it to the left to implement the multiplication. And then the number of shifts is specified by register CL, and we're first doing it for the first multiplicand, because with this formula we can say multiplier times this plus multiplier times this and plus multiplier times this, because so that we basically open the parentheses. Okay, and so these are the steps, and so when we're shifting, we're doing multiplication. In this case, it's actually this first multiplication that we're doing. And then we store the result of this first multiplication in the product. Then what we do, we reload the multiplier. We need to start with the fresh multiplier, not the one that's being already multiplied. We just repeat it for the same multiplier. That's important. And so we now multiply by this power of 2. And we do it by shifting left multiplier, so that implements this. And then we add the result to the product. So we implement this part right here in this instruction. And then again, we just repeat everything here. Again, multiplier, the final multiplicand that we're using right here, doing the multiplication by shift left and adding the result to the final product. So now we should have our product in place. Let me just make sure that my syntax is all correct before I proceed further. I just want to build, make sure. Oh, okay. So the product, let me see what is wrong with the product. I just have to add product variable to my data, I think. I don't think I've added it. Yeah, so I'll just add it as the next thing. And of course, this is also a double word. Okay, so it's not going to be initialized because we set it to 0 every time we do the computation. Okay, so here, let's try this again. All right, so this is the place where we manipulate it. Okay, so now it holds together, and this is fine. So to test this, let's first display the result as a decimal output. So let's add another section right here, which is display the results. So we take our product, and call double word to ASCII converter, specifying the target buffer. Hopefully this conversion works. It always works. And then we display the result, print the result, and print a new line. And then we can proceed to this display, but of course to display in binary form, we need to again make sure that we reload the register. Right, so display in binary form. Here we can say display in decimal. In decimal form, here we say display in binary form. So let's make sure that we can build this portion. And so then finally, I think what would be nice is to just display the pause, basically just before continuing to the next set of inputs, because part here says that we should repeat in endless loop this entire program. So what we can do is after we make a display, we can output a message and just wait for them to hit the enter key. Okay, so something like this. Just yeah, pause before exit. We already have a comment here. So I need this come up with some kind of a prompt for the user. We can add a prompt to our constant data segment. How about just right at the top we can say prompt for the pause. Just hit enter to close. Okay, so this is what this looks like. At this stage, basically do the computation, display the decimal form of the number, then display it in binary form. So let's see how everything works. So first we need to be able to build. So we build fine. And then let's run our program. So I'm just going to press Ctrl F5 to execute it. So input multiplier. So we start with the multiplier. So for the sake of simplicity, how about we say 10? And then the first multiplicand is going to be, so let's bring into the view our formula. And let's test this with the 0, 0, and 0. So of course, anything raised to the 0th power should end up with the value 1. So we should be, so the result of this should be 1, essentially 1 plus 1 plus 1 is 3, and 10 times 3 should be 30. Okay, so this is the result, and this is the binary version of decimal 30. So hit enter to close. Oh yeah, we close the window. But how about we just loop back to the top, right? So instead of closing. So this is what I was planning originally, but let's just make it continue. To continue. Okay, and as we let them continue, we can just jump to the multiplier input, right? So at the bottom of our program, after the pause, instead of a return, I'll just comment this out, we just unconditionally jump to the top, right? So let them do the next, and so we can even have a more recognizable comment, repeat forever. Okay, so yeah, and so build, and let's do a few more test cases with what we have. I press Ctrl F5 to restart the program and again bring to view our formula. So let's try, again, I'll use 10 because it's easier to track. And how about 1, 1, and 1? So with 1, 1, and 1, it's 2 raised to the first power. So this is 2 plus 2 plus 2. 10 times 6 is 60. Okay, so that's 60 right there. And let's just test a little bit more. So input multiplier. So we can try something like 1, 1, 2, I meant to do 1, 2, 3. So let's do just this one, and that's 3. And yeah, so here multiplier 10 and 1, 2, and 3. So it should be 2 plus 4 plus 8. That should be 14. So 10 times 14, 140. Okay, so that's 140. All right, so one more thing I think that would be kind of nice to have in the code to kind of like finalize what we have done is to display, and I'll just close this program, to be able to display just a separator line. So let's go here and maybe we can add just a line, just a big line like this. Maybe we can make it a little bit smaller to fit the sizes of our outputs like this, but just display it as a separator. And so we can use this text line output right at the top of the first input. Here output a line and then a new line. Like this, and here we can then say repeat all. Right, so this is new label, repeat all, and I will change my bottom jump to repeat all. In fact, we can say repeat forever. Okay, so that would be the top of our code, to repeat everything forever. So I think it's just aesthetically a little bit easier to track the, and test. Okay, so now hit enter to continue, and we have a clear sort of like a separation in this display.